Hello and welcome back to Sheaff Math. In today's lesson, you are going to learn about finding the distance between 2 points using the distance formula. Now, before we talk about the distance formula, let's look at what our goal is. Okay, so we've got 2 points, and so here are our 2 points, and what we're trying to do is find the distance between these 2 points. Okay, that distance. It helps to visualize it if you look at it on a graph. And so we've got our -4, 1, and 3, 5 on the graph, and we're trying to find that distance. Now, the way that we find it is technically using the Pythagorean theorem. Now, do you remember what the Pythagorean theorem was? A squared plus b squared equals c squared, right? Well, what we do is we actually draw a base line and a height line, and you could find the distance using the Pythagorean theorem. But drawing out a graph, graphing the 2 points, doing the slope or the triangle, the right triangle, and solving it that way takes a long time. And so mathematicians came up with a real easy way. They took the Pythagorean theorem and worked it out, and they came up with this magical thing called the distance formula. And it is very similar to the Pythagorean theorem because it actually is the Pythagorean theorem in a different way. Now, let me explain to you a little bit about this because it probably looks pretty daunting. The x2 minus x1, that is finding the base of our triangle on that graph, if you remember. And the y2 minus y1 is finding the height of that triangle. Okay, so that's technically what's going on here. And so we are going to try to solve this. Now, let's say you're given 2 points, 2, 6, and 5, 10. We use this distance formula, and what we're going to do is we're going to subtract the x's, and if you remember which one is x1 and y1 and x2 and y2, the first point represents the first and the second, or the first x and the first y, and the second point represents the second x and the second y. And so we are going to subtract the x's, x2 minus x1, and subtract the y's. And you can see 5 minus 2 and 10 minus 6. Now we're going to simplify inside those parentheses, and we end up with a 3 and a 4. Everybody see that? Now we're going to simplify those squares, 3 squared and 4 squared, and we get 9 and 16. And then we add those together, and we get a perfect square inside there. We're very lucky on this one. It's very unusual to get a nice perfect square because the square root of 25 is 5. And so that is the distance between 2, 6 and 5, 10. 5 units. All right. Let's try another one. Let's say here are our 2 points. We're going to use our distance formula again. Reminder of our x1s and y1s and all those. We're going to subtract 4 minus -3 and 7 minus 2. And so if you notice I put the -3 in parentheses, always do that with negatives just so you don't get tricked by that minus negative, which turns to a plus. And we end up with a 7 and a 5 in those parentheses. Underneath we get 49 and 25 after we square those numbers. And when we add them, we get the square root of 74. Now the square root of 74 is not a perfect square. If you put this in a calculator, it would go on forever, and it actually cannot be simplified anymore. Now there are some square roots we call radicals that can be simplified, and we're going to try that on the next one, and I'm going to show you what I mean. Now this one is the one with a little twist on it. We've got 2, 3, and 4, 7. Use our distance formula again. we're going to subtract our x's and our y's, and we get 4 minus 2, 7 minus 3. Now somebody asked once, does it matter if you subtract the x2 minus x1? What if you subtracted the x1 minus the x2? You'll actually get the same answer. It's just that you're getting the true distance and dealing with less negatives, in my opinion. All right. So we simplify inside the parentheses. We get 2 and 4. We square those. We get 4 and 16. And we get d equals square root of 20, which is not a perfect square. But it can be simplified. And what do I mean by that? Well, I did do a video on simplifying radical expressions that goes into more depth. But for right now, we're going to do it really quick. If a number inside a square root has a factor, or a number that multiplies it, that is a perfect square, we can simplify it. And so since 4 is a factor of 20 and that is a perfect square, we're going to do this. We're going to write 4 times 5 underneath the square root, and then we're going to separate those two radicals, or those two square roots. Square root 4 times square root 5. Once we isolate that square root 4, we can simplify it. And we get 2 square root 5, 2 times square root 5. And that's what I mean by simplifying a radical expression. You might want to check out that video to learn more about that. All right, well, I do encourage you to use paper on this. Don't try to do these in your head. Work out every detail on it. If you need more help with this topic, rewatch it again and pause it if you really need to learn more. And I thank you for watching. We'll see you next time.